tutorial explains the heat transfer analysis of an axisymmetric plate with convective and radiative boundary condition. The geometry is 0.05 meter by 0.1 meter. The element is 2D axisymmetric. Thermal conductivity along x and y direction is 1 watts per Kelvin. Convective film coefficient is 30 watts per meter square Kelvin. And ambient temperature is 373 Kelvin for the convective boundary condition. For radiative boundary condition, the emissivity is 0.9 and temperature of surroundings is 300 Kelvin. For creating the 2D axisymmetric plate model, first go to Geometry, Key Point, Create by XYZ. Click the coordinates to be created. First, 3, 0, 0. And click Apply. The first point is created. Next point is 3.05. (0.10). Click Apply. The 2 points are created. Click on the labeling. We can see the first and second point. Next, go to Geometry, Surface, Create, Recto P. Snap to point and select the corner points. Now the surface is created. We can label it and see the first surface. Now go to Mesh menu, FE Mesh, select Quad. In the parameter box, select the first surface. You can give an initial size as 0.5. We can select the method to map and select the divisions. For setting the subdivisions, we can click on each edge of the surface and adjust the subdivisions. First edge we can set to 5 divisions and the second edge we can set to 1 subdivision. After setting proper subdivisions, click Apply. Now the mesh surface is ready. We can erase the surface and view the elements. Next, go to Mesh, Element, Modify, Convert. To convert the quad 4 elements to quad 8 elements. And from the drop down box, you can select to quad 8. Now the 8 node elements are created. We can find that from the entity list and select the element and see that it's written that quad 8 element. From the mesh element, modify, type, we can set the element type to axisymmetric. For that, select all the elements and the element type select axisymmetric and click Apply. Now set the analysis type. In that, select it turns a steady state and click Apply. Now select the load and boundary conditions. Heat transfer BC nodal temperature, convection, add. In the parameter box, select click on the element label to see the element numbering. Select on edge. In the element edge or face, select edge 2 of element 5. In the convective filling coefficient box, type the convective filling coefficient. Next, type the ambient temperature and click apply. Now the convection boundary condition is set. Next, again call load BC, heat transfer BC, radiative emission, add. Select on edge. Select the edge 4 of element 1 and give the emissivity value as 0.9. Now set the temperature of surroundings at 300. Click apply. Now the boundary conditions are set. Now we can give the material properties from property, material, thermal, add. Select all the elements, give the material data. The conductivity values are 1 and 1 along x, y direction and click OK. Now the material properties are set. Now save the file to appropriate directory. After saving, click Run Solver to execute the file. Click S for confirmation. Finished successful message is shown on the message box. Next, for temperature distribution, click Pause, Contour, Temperature, Apply. Here you can see the temperature distribution with convection and radiation boundary condition.